Balancing redox reactions. The first thing we need to do is to determine the oxidation number of each element. So if we look at this sample reaction, oxygen is a 2 minus, arsenic is a 3 plus, oxygen and NO3 minus is a 2 minus, N is a 5 plus. And we go across, H is always a plus, oxygen is a 2 minus. That means that AS is a 5 plus. And then in NO, O will be a 2 minus and N will be a 2 plus. So if we remember Leo goes Gur, lose electrons oxidation, gain electrons reduction, then we can find that AS goes from a 3 plus to a 5 plus, which means that that's oxidation, and our N will be reduced, going from a 5 plus to a 2 plus. Then we write down our half reactions. Our oxidation half reaction will be AS2O3 yields H3ASO4. Now I went ahead and put a 2 in front of that to balance my AS's. And then we'll break up our half reactions, and we can before I write down the reduction half, we'll go ahead and start balancing the oxygens out. We need to add H2O. This reaction wasn't an acid, so we'll add H2O and H pluses to balance our oxygens. So we find that we have 8 oxygens on the product side, so we need to get 8 on the reactant side, so we put a 5 in front of the H2O, and that gives me 8 oxygens, and then I need to add 4 H pluses to the product side to balance out my H's. The reduction half reaction is NO3 minus yielding NO. We need to balance out our oxygens again with H2O and H pluses, and we'll add the H pluses to the reactant side, and the H2O will go on the product side. We're going to need 2 H2Os to balance out our oxygens, and then we'll need to put a 4 in front of H plus to balance out the H's. The next thing we're going to do is balancing our charges by adding electrons. And so in the reduction half reaction, we have 4H plus plus NO3 minus. So that's a plus 4 and a minus 1 is a total of a plus 3 charge. We have no charge on the product side, so we need to add 3 electrons to the reactants. Then if we go over to our oxidation half reaction, we're going to look at this, and I can see by looking at it that I have a no charge on my reactants and a plus 4 on my products, so I need to get those to be equal. So I need to add 4 electrons to my product side. The next step is step 5, and we need to multiply each half reaction by some common denominator to get the electrons to be equal. So we have 4 electrons and 3 electrons in our oxidation half and reduction half. So we need to multiply the oxidation by 3 because 3 times 4 will be 12, and if we do the reduction by 3, we'll get 12 electrons on that side. So rewriting the equations, multiplying by the 4, in the reduction half reaction we get 16 H pluses plus 4 NO3 minus plus 12 electrons yields 4 NO plus 8 H2Os. And then when we go over to the oxidation half reaction, we'll find that we have 3 AS2O3s plus 15 H2Os yields 6 H3ASO4s plus 12 H pluses plus 12 electrons. The next thing that we need to do is go ahead and add our half reactions back together. So when I do that, I find that I have 3 AS2O3s plus 15 H2Os plus 12 electrons plus 16 H pluses plus 4 NO3 minuses, yielding 6 H3ASO4s plus 12 H pluses plus 12 electrons plus 4 NOs plus 8 H2Os. So that takes us through step 6. In step 7, we're going to cancel out our like terms. So when I look at this, I've got 15 H2Os on the reactant side and 8 on the product, so I can cancel out the 8 H2Os and change the 15 to an 8. My H pluses I can cancel out on the products and give myself 4 H pluses in the reactants, and then cancel out my 12 electrons on both sides. So rewriting this just to clean it up a little bit, we have 3 AS2O3s plus 7 H2Os plus 4 H pluses plus 4 NO3 minuses, yielding 6 H3ASO4s plus 12 hydrogens plus 4 NOs. Then the final step is we want to check our electrons, our charges, and our atoms. So if we check, we make sure we have no electrons left. Our charge, we have no charge on the reactants and no charge on the products. And then we want to make sure that all of our atoms are balanced out. And I've written these in. And so we should find that we have 6 AS's on the reactant side and 6 on the product side. I'm going to save oxygen for last because they're all over the place. We'll find that we have 7 times 2 is 14 and 4 is 18. H's on the products, on the reactant side, and there's 18 on the product side. And then our nitrogens, we have 4 on each side. And finally, we want to look at our oxygens. And on the product side, which is a little easier to see because they're only in 2 places, 6 times 4 is 24 and 4 is 28. And then on the reactance side, we have 9 in 3As2O3. We have 7 in H2O and 12 in NO3, which gives me 28. So we're all balanced. This is how you balance a redox reaction.